Hello. So one more video on kind of review topics for the probability unit in preparation for the quiz on Friday. So let's jump right to it. Okay. So for the quiz, you'll have to know some basics of probability theory. So you should know the basic terms. So the building blocks like sample space is set of all possible outcomes of a random experiment. Events are some subsets of sample space. And there's some rules about probability measures, right? So probability could be, it's a way to assign a number to an event where the probability could be between 0 and 1. So it can be negative and it can be greater than 1. And there's special types of events that we discussed. So mutually exclusive events, independent events, and equiprobable events. And there are some rules on how to compute probabilities for each of those situations. So you should know them and how to compute probabilities associated with them, because you might get questions about them. You should be able to compute certain probabilistic events like Monty Hall type of probabilities where you have some doors and you pick one and then some choices are eliminated and you ask to switch what the true probabilities of those situations are. And it's easy to put a spin on it, right? So you can change the number of prizes behind the doors, you can change the number of doors, you could also change the types of the number of false doors that's revealed and so on. It's also easy to make variations on the Russian roulette problem that was given on survival probabilities. What's the probability if your strategy of survival was pulling the trigger twice in a row, or pull a trigger once and then spin before pulling the trigger again. And I don't have it listed here, but birthday double up probabilities, those you should be able to compute as well. And drawing balls from an urn, right? So we learned some techniques about probability trees with branches with weights that you multiply. So you should be able to compute problems that involve those things as well. And finally, you should definitely be able to compute expectations. So if you're given possible outcomes and probabilities of getting those outcomes, you should be able to put those together and compute expectations of those as well. And other things that you should know is that in probability, you could have weird situations like non-transitive dice, or situation where it's most likely that A could be B and B could be C, but C could be A. And you could have tricky situations like Penny's game as well. So that's a little bit more complicated version of non-transitive situation where person who picks second has an advantage. In the worksheet where we talked about laws of large numbers, we also talked about how bad human intuition is when it comes to trying to come up with random sequence. So you should know the basics of those as well. So if you don't remember, please revisit the worksheet and the video. And as far as paradoxes goes, so we covered 5 different situations that were named paradoxes. So Monty Hall paradox, birthday paradox, and Forbear's paradox are all situations in which your gut feeling probably gives you the wrong answer. So if you actually compute it carefully, you can get a correct result, which might not have been the first thing that popped into your head, like, oh, this should occur. But if you compute it carefully, you get to the right answer. So there really isn't a paradox after all. It just seems paradoxical because we have bad intuitions about the situation. St. Petersburg paradox is a situation where you get an expectation that's infinite. And you just have to be aware that that is a possibility. It's possible for finite things to have infinite average. So as long as you can swallow that, that's a possibility. There isn't anything paradoxical about St. Petersburg paradox either. It's just infinite expectation that could happen. Two envelopes paradox was a situation where if you carefully look at the problem setup, you weren't actually given enough information to solve the problem. So that's like a trick situation, I think. So you should be aware of the resolution of these paradoxes. And if you were given some like a slight variations on these, I hope you'd be able to point out how to go through it slightly differently to solve the problem. Let's see. I think that's all you need to know for this quiz. So study up, good luck, and stay healthy.